Okay, here are the answers to the review sheet on trigonometry. I'm going to do it one page at a time, so you can always skip ahead, fast forward to the end of the page, or to the page that you're on to find out what the answers are supposed to be. So right from the very beginning, we have a right triangle, which for our work in geometry is the only triangle you can use when you're trying to figure out how long a side is using SOHCAHTOA. So it all begins with good labeling. There's the angle. Across from the angle would be the opposite side. The biggest side of the triangle is always across from the right angle, and that's our hypotenuse. They're asking which equation can be used to find C. Knowing your trigonometry ratios is absolutely necessary. You do not get them on the exam, and the formulas look like this: SO, CA, and TOA. All right, we're looking for the opposite side. So the only formulas that could be used would be these two, because those are the only ones that have the opposite in them. Looking at the ingredients that we have in the question, they're telling us what the hypotenuse is, so that means that it can't be TOA, or tangent. It most likely will be the first one, which would be on sine. So sine of the angle. Sine, cosine, and tangent are always connected to the angle. The sine, cosine, and tangent can't live without the angle. It's sort of like the oxygen for us to live. It needs the angle to survive. So this would be sine is opposite over hypotenuse. If we're following the formula, it's C over 15. And being careful to circle the right one, we're looking for the one that can be used. So that is one of the possibilities that we could use to figure out the answer. Looking at question number 2, no picture. So it says there's a base angle of an isosceles triangle that measures 30 degrees. So I'm going to try to draw that as realistically as I can. If you notice, I've made this angle here obtuse because a 30-degree angle here means for a 30-degree angle here, which leaves 120 degrees for the angle at the vertex. Well, I've drawn the picture of the isosceles triangle with the base angles being 30. It says the length of one of its legs is 12. Well, it's isosceles, so the other side would be 12. They want to know what is the length of the altitude drawn to the base. Well, an altitude is always perpendicular to the base, and that's where our right triangle is formed. And to solve this question, we're not even going to use the other part of the picture. We're just going to focus in on just this part right here. So we're looking for how long this side is here. And to do that, we could use some trigonometry. That is the opposite side. And again, we're given the hypotenuse. So of the choices of SO, CA, or TOA, it would have to be the first one. It's the only one that has the O and the H in it. So I'm getting the sine of 30 equals the opposite side, which we don't know, over the 12, which we do. And this one finishes by cross multiplying. 1 times x is x. 12 times the sine of 30. If I type that into the calculator, it gives me exactly 6. And the answer looks right in the picture. I tried to, even though the picture wasn't drawn for us, I tried to make the picture look realistic, and my effort there paid off because I've got a way to check visually that the answer makes sense. Question number 3 is when we're looking for the angle. And once again, I'm noticing that the angle that I'm looking for is in a right triangle. And that means I can use SOHCAHTOA to help me figure out the answer, or maybe the Pythagorean theorem. To use trigonometry to figure out that angle, I'm going to need to know 2 sides in the picture. And so far I only have one side, the hypotenuse. But that 8 on the right would also have to be 8 here, because both of them represent the height of that trapezoid, or the altitude of the trapezoid. So what side are they giving me? They're giving me the hypotenuse, and they're also giving me the opposite side. So it wouldn't be so, because we have O and H. Oh, no, it would be so. We have O and H. So the S is for sine, and sine, cosine, and tangent are always attached to the angle. As I mentioned before, the angle and sine and cosine and tangent are always holding hands. They're BFFs. So using the numbers that we know, it's 8 for the opposite, 10 for the hypotenuse. And when we're looking for the angle, you do not cross multiply. Instead, you have to use the second button on your calculator to figure out the answer. So you have to type in second sine to bring up the inverse sine command on the calculator. And then all it's left to do is type in the O over the H and let the calculator figure out the answer for us. So me doing that right now, I got the answer on my screen right now. But before I even do that, why don't I just take a look at the choices and see which answers probably make the most sense and which ones don't make sense. Well, it doesn't look like it's 80 degrees right off the bat. It looks like it's not almost a 90-degree angle, but it does look large. And because it looks large to me, I bet right now it's not 37, because that seems like that would be too small for that angle. My calculator tells me it's about 53, and that's making total sense in the picture. For question number 5, again, this is one where there's no picture, and I try to put a few of these questions on the review sheet. So it says right triangle DEF, where angle E is the 90-degree angle. So I'm going to draw what they tell me. DE is worth 8. This must be point F. EF is worth 15. And FD is 17. This is an odd question because they don't want me to actually figure out any of the angles or any of the lengths. They just want me to find out what the tangent of angle F is worth. Well, tangent would be T, so it's TOA that I'm looking for. If angle F is the angle that I'm interested in, which it is, I'm going to count angle F as the target in my mind. And if I'm looking for the opposite side over the adjacent, it would be the 8 over the 15. And that's all that's needed to be done. They're not asking you to find the angle. They just want to know what the tangent of it is worth. If you wanted to find the angle, you would do second tangent and then just dial in 8 over 15. Again, they're not asking you to do that, but if they did, it would be just like that, and it would be about 28 degrees. And my picture's drawn pretty realistically, so that 28 does look correct as well. Question number 6, again, no picture. Let's see what this one's all about. In triangle ABC, angle B is the right angle, with angle A being 35. So angle B, angle A is 35. So I'm taking my time trying to make a picture that looks pretty accurate. Point C would have to be here. And it says AB is worth 10 inches. And they want me to find the volume of a solid formed by continuously rotating AB, rotating it about AB. So I have to picture that in my mind, and I'll kind of write a sketch of it. So they want me to spin this triangle around AB over and over and over again. And if I did that, it would actually make a three-dimensional shape, a cone. All right, so now I'm in good shape. I've got my picture drawn, and I'm after the volume, so I need all of these ingredients, the R and the H, to figure out the volume. So if I go to figure this out, I notice that I don't know the radius, but I do know the height of the cone. The height of the cone is 10 inches tall. So all that's stopping me from figuring out this answer is how long the radius would be. And surprise, surprise, we've got a right triangle in the picture, and you're going to be using SOHCAHTOA to help you figure out the missing side. So the opposite side is what I'm looking for. They're telling me that the 10 is one of the sides. That's the adjacent side. So of the choices of SO, CA, or TOA, the one that I'm going to need would have to be the one that has the O and the A in it, which would be TOA. So I put in tangent on my paper, and then always next to that is the angle every single time. And then the opposite side's what I'm looking for, and the adjacent side's 10. So this one finishes by just doing some cross multiplying. 1 times R is R, and 10 times the tangent of 35. Just have to throw that into the calculator, which gives me about 7. So the radius is about 7 long. It's very close to 7, actually. And since I know the radius is 7, I can put that in and then use my calculator to get the answer to the nearest tenth. So the volume would be 49 times 10 times pi divided by 3, which gives me about 513.1 cubic inches.